Alright, we want to look at the third part of electricity, electric energy and power. Okay, just like in mechanics, we have mechanical energy and we have mechanical power. For example, one of the forms of mechanical energy is potential energy and kinetic energy, and we know these things have their formulas. For example, just to remind us, the formula for potential energy is mgh, while the formula for kinetic energy is half multiplied by mv squared. But here we are going to see the formula for electric energy and power. The electric energy is different from this, which is mechanical energy. But generally, energy is the ability to do work. So it doesn't matter whether it is mechanical energy or electrical energy, but that ability to do work is what we call energy. Some text can say energy is the capacity to do work. All right, so that gives us the fact that energy and work done have the same units. Okay, so take note of that. The unit for energy is joules, which is capital letter J. The same thing for work. The unit for work or work done is also joules, capital letter J. Now, we know that electricity is a form of energy which can be used to do work whenever it is converted into other forms of energy, such as heat. So when electricity is converted to heat, work is done. And there are devices that incorporate that change of energy. An example is electric cooker, kettle. Okay, these devices can convert electricity into heat energy. Then there are other devices that can convert the same electricity into another form of energy, like mechanical energy. Those devices are called motors generally. Okay, so we have things like blenders, grinding machine. They are powered by electricity, but they give mechanical energy or rotation. Okay, so also electricity can be converted into lights, and devices that do that conversion are bulbs generally. Electricity can also be converted into sound. This can be found in loudspeakers. Okay, so there are other forms in which electricity can be converted into, and there are special devices that help this conversion process. Now, from the definition of volts, we say volts or 1 volt is the energy we get, okay, per coulomb, or the energy that is released when 1 coulomb of electricity moves from one point to another. Okay, so that gives us that volt or voltage, V or PD, V equals to energy per coulomb. When we cross multiply, energy becomes VQ, or volt multiplied by coulomb. This is equation 1. Okay, that's the formula for energy. Then we can also progress and do something with that. From the definition of current, we say current is the rate at which charges flow, or it is the quantity of charges per unit time. So from this formula, Q becomes equals to IT. Now, if we substitute this formula into equation 1, remember that equation 1 is energy equals to VQ. Okay, so since energy is equals to VQ, now this is Q. We can fix Q in here. So energy is V multiplied by Q. What is Q? Q is IT. Okay, so energy is equals, when V multiplies IT, you have VIT. So this is the standard unit for electric energy. Okay, so electric energy is equals to voltage multiplied by current multiplied by time. All right, so take note of that. The next thing we are going to look at now is electric power, electrical power. Now, generally from our definition of power, power is energy expended or used up per unit time. So, or we can also say power is the rate at which work is done. So power is also energy, but it is energy measured per time. Okay, so the unit for energy can be joules per second. That is sorry, the unit for power can be joules per second. That is the rate at which energy is used up. But the SI unit, that's the standard unit, is power. Okay, is watts rather. So the SI unit for power is watts, which is capital letter W. So watts is actually what? Joules per second. This is the derived unit for power. This is the SI unit for power, which is the standard unit. So from that definition of power, energy expanded per unit time or expended per unit time, this is the formula for power. Power is energy per time. When you measure energy per given time, what you get is power. So from that definition, we can now proceed further and say, since energy from our previous calculation or illustration is VIT, we can now say power is VIT divided by time T. So when you look at this, something will happen here. Time will cancel time. So eventually we have gotten our formula for power. Power is VI, or power is IV. Okay, so take note of this. This is the formula for power. Alright, so just to summarize, electrical energy, the formula is IVT, power is IV. Alright, so that is that. With these two formulas now, we can now go ahead to solve some questions under electrical energy and power. So the number one question says we should calculate the power delivered by a three-phase line if its voltage and current are this and this. So we are given the voltage. So solution for this problem, voltage is given, V is 132 kV, kilovolts. We are going to change this kilo, okay, to volts. So this is what we do. 132 times, anytime you get kilo or K, that's means 1000. So 1000 then volts. We'll multiply this, we get 132 followed by 3 zeros. 1, 2, 3. That is the voltage. Then the current, according to the question, current is 60 amps. So with these two values, we can calculate the power. What's the formula for power? Power is just what? IV. So power is, what is the I? The I is 60. What is the V? The V is 132, 1, 2, like this. So when you multiply 60 by 132000, you are going to get 792 followed by 4 zeros. 1, 2, 3, 4 watts. Since this number is a very big number, we can change it to kilowatts. And to change watts to kilowatts, you divide it by 1000. So power now is equals to 792, 1, 2, 3, 4 divided by 1000. Once we do that, we are going to get kilowatts. So power is equals to 3 zeros will cancel out. 1, 2, 3 will cancel 1, 2, 3. So leaving us with 7920 kilowatts. So that is the power delivered. Okay, so take note of that. Now for the second question, this one says an electric kettle contains a 720 watt heating unit. From this unit here, okay, we know this is power because of the watts. So the power is given. The power is 720 watts. So always observe the power. Once you are giving something in joules, you know that is energy. Once you are giving in watts, that is power. Okay, V is voltage, ampere is current. So take note. Now calculate the current. So we are looking for I. I is unknown. It takes from a 240 volt mains. So the voltage is 240. Okay, so with this information, we'll write the formula for power because we know power. Power is IV. So what's the power? 720. So this becomes 720 equals to I is unknown, open bracket, V is 240. So here now we're looking for I. We'll divide both sides by 240. Okay, so what we'll do, the division, we have 720 divided by 240 is equals to I open bracket 240 divided by 2. For this cancels this. So when you divide this, you get 3. 3 amps equals to current. Current equals to 3 amps. Final answer. Okay? So I'll see you in the next class.